Good morning.
Good morning, sir.
Okay.
Good morning, sir.
Okay, good morning. Good morning. Is this the problem we discussed in the earlier class? Find the radius of curvature for the curve y square is equal to 4a square into 2a minus x divided by x. I think this is the last problem we discussed in the earlier class, correct?
Yes, sir.
Okay. We'll move on to the next problem. Find the radius of curvature for the curve x square into y is equal to a into x square plus y square at minus 2a comma plus 2a. Point is specified. Find the radius of curvature. It's a little difficult problem. Find the radius of curvature for the curve x square into y is equal to a into x square plus y square at minus 2a comma 2a. Let's rewrite this equation. X square into y is equal to a into x square plus a into y square ay square. This is the given curve. Clearly, it is a Cartesian curve expressed in terms of x and y. And what is required now? Rho is given by 1 plus y1 square whole power 3 by 2. This divided by y2. That means y1 and y2 are required. We shall find these two derivatives first. To find y1, differentiate the given equation throughout with respect to x. You do this. First, you differentiate x square into y with respect to x. Using product rule. X square into derivative of y with respect to x is dy by dx or y1. In either ways, you can write that. X square into derivative of y is y1 plus derivative of x square is 2x into y. Keep second function as it is and differentiate first function. Derivative of first function x square is 2x into y. This is equal to, here a is a constant, derivative of x square is 2ax. Collectively it is 2ax. Plus derivative of a into y square. Keep this a as it is. Derivative of y square is 2y and that of y with respect to x is dy by dx or y1. Now transform all the terms which include y1 to left hand side and the other terms to right hand side. What you get here is x square into y1. This is first term on left hand side, this term, x square into y1. Transform this term to LHS. You get a minus 2ay y1 is equal to 2ax. This term. Now transform this term to RHS, minus 2xy. Here take y1 as common factor. As y1 comes outside, what you get here is x square minus 2ay. This is equal to 2ax minus 2xy. Therefore, y1 is equal to 2ax minus 2xy divided by x square minus 2ay. This is y1, 2ax minus 2xy divided by x square minus 2ay. And this derivative is required at the specified point. What is the specified point? X is equal to minus 2a and y is equal to 2a. Substitute. What will be the denominator? X square, x is minus 2a whole square is 4a square. Minus 2a into y. Y is also 2a. 4a square minus 2 into 2 is 4. A into a is a square. 4a square minus 4a square is 0. That means this denominator will be 0 at x is equal to minus 2a and y is equal to plus 2a and numerator is a finite quantity. finite quantity divided by 0 is not defined, it is called infinitive. In such cases, we take the reciprocal. We take the reciprocal. Reciprocal of dy by dx is dx by dy. It is denoted by x1. It is denoted by x1. Now interchange numerator into denominator and denominator to numerator. The fraction will be x square minus 2ay divided by 2ax minus 2xy. Now numerator will be 0. X square, x is minus 2a. Therefore, x square is minus 2a whole square, that is 4a square, minus 2a into y, and y is again 2a. 2a into 2a is 4a square minus 4a square, 0. Numerator is 0, denominator is a finite quantity. 0 divided by any finite quantity is 0. Therefore, x1 is equal to 0. This is x1. x1 means dx divided by dy. This is a derivative with respect to y. Therefore, to find second order derivative, we differentiate with respect to y. Differentiate with respect to y. Using quotient rule. Denominator into, that is 2ax minus 2xy, into derivative of numerator. Derivative of x square is 2x and the derivative of x with respect to y is x1. Minus derivative of 2ay with respect to y is 2a. 2a is constant. This derivative of y with respect to y is 1. Minus numerator x square minus 2ay into derivative of denominator. 2a into derivative of x with respect to y is x1. Minus 2x into derivative of y is 1. Therefore, minus 2x. Derivative of minus 2x is minus 2x1 into y divided by denominator square. This is the second order derivative. This is clear? Numerator into derivative of denominator 2a into derivative of x is 2a x1. Use product rule here. Minus 2x into derivative of y. Derivative of y is 1, therefore minus 2x. Now derivative of minus 2x is minus 2x1 into y. This is what I have written here. Now this derivative at minus 2a comma plus 2a, x is equal to minus 2a and y is equal to 2a and x1 is equal to 0. Substitute and simplify, you get minus 1 divided by 2a. x2 is equal to minus 1 divided by 2a. You do this simplification by yourselves at your home. Now substitute. Substitute to find a radius of curvature. Radius of curvature rho is equal to radius of curvature rho is equal to 1 plus x1 square and x1 is equal to 0 whole power 3 by 2, 1 power 3 by 2 divided by x2 and x2 is minus 1 by 2a. I do not consider this negative sign because rho is always positive. You just take 1 divided by 2a. This is equal to 2a. Radius of curvature is 2a. For your doubts, you can unmute and ask. Make a note of this. Is this over? He's making
Yes, sir.
the notes over? Okay. Find the radius of curvature for the curve. Y square is equal to a square into a minus x divided by x, where the curve cuts or meets x-axis. Find the radius of curvature for the curve. Y square is equal to a square into a minus x divided by x. How do you approach this? Point is not specified. First, we shall find the point at which rho is to be determined. The curve meets x-axis. This horizontal line is x-axis. This vertical line is y-axis. At the point where the curve meets x-axis like this, that means the point lies on x-axis. On x-axis, y coordinate is always equal to 0. Therefore, y is equal to 0. When y is equal to 0, y square is 0. 0 is equal to a square into a minus x divided by x. On x-axis, y coordinate is always 0. Therefore, a square into a minus x is equal to 0 into anything is 0. A square into a minus x is equal to 0 into x is 0. The product of these two terms equal to 0 implies at least one of the two terms is equal to 0. That is either a is equal to 0 or a square minus x is equal to 0. But this a is a positive quantity. This is greater than 0. Therefore, you cannot equate this a square to 0. That means a minus x must be 0. Therefore, x is equal to e. Therefore, the ordered pair x comma y. X is a and y is 0. This is the point at which rho is to be determined. A comma 0 is the point on the curve at which we find rho. This is the point. Next, we find the derivatives. Y square is equal to a square into a divided by x. That is a cube divided by x. A square into minus x divided by x is minus a square. This is the given curve. Differentiate with respect to x. Derivative of y square is 2y. Derivative of y square is 2y, and that of y with respect to x is y1. This is equal to, here a cube is a constant, keep it as this, and derivative of 1 by x is minus 1 by x square. A square is a constant, its derivative must be 0. Therefore, y1 is equal to minus a cube divided by 2x square into y. Minus a cube divided by x square into 2y is 2x square into y. This is y1 dy by dx. And this y1 is required at the point where x is equal to a and y is equal to 0. Since y is equal to 0, this denominator will be 0. Numerator is a finite quantity which is not defined. It is called infinity. Therefore, y1 becomes infinity. In such cases, we take the reciprocal. Reciprocal of dy by dx y1 is dx by dy or x1. Therefore, x1 is equal to, we'll just take the reciprocal. Therefore, x1 is equal to x1 is equal to minus into, just interchange numerator into denominator and denominator into numerator. You get 2x square y divided by a cube. Since y is equal to 0, this numerator will be 0. 0 divided by any finite quantity is 0. Next, this is x1. x1 is dx by dy. This is derivative with respect to y. Therefore, again we differentiate with respect to y, not with respect to x, because this derivative is with respect to y. Derivative of x1 is denoted by x2. Here minus 2 divided by a cube is a constant. Keep it as this. You just differentiate x square into y using product rule. X square is first function. Keep it as this. Derivative of y with respect to y is 1 plus derivative of x square is 2x into derivative of x is x1 into y as this. Second function as this. This is equal to minus 2 divided by a cube. Put x is equal to a and y is equal to 0 and x1 is equal to 0. Since x1 is equal to 0, this entire term will be 0. x square will be a square. Therefore, this is equal to minus 2 divided by a. Rest is very simple. Radius of curvature rho is given by 1 plus. Now the roles of x and y are interchanged. Therefore, the formula will be 1 plus x1 square whole power 3 by 2 divided by x2. We just substitute. X1 is 0. Therefore, numerator is 1 power 3 by 2. That is 1 divided by x2. You just leave this negative sign. Take the magnitude only. That is 2 by a. Therefore, this is equal to a by 2. Radius of curvature is a by 2. Is this clear?
Yes, sir.
Okay, make the note of this. Find the radius of curvature for the curve y is equal to e power x at the point where the curve cuts x-axis. At the point where the curve cuts y-axis, not x-axis. I'm sorry, y-axis. Find the radius of curvature for the curve y is equal to e power x. First, you find the point on y-axis at which the curve meets y-axis. This vertical line is y-axis and this is x-axis. Suppose this is the point on y-axis at which the curve meets y-axis. On y-axis, x coordinate is always 0. Since x is equal to 0, the given equation will be y is equal to e power 0 and e power 0 is 1. Therefore, x comma y will be 0 comma 1. X is equal to 0 and y is equal to 1. This is the point at which we find rho. 0 comma 1 is the point on the curve at which rho is to be determined. Rest is very simple. You do this. You must keep a notepad and pen with you. Y is equal to e power x. Differentiate both sides with respect to x. Derivative of y is dy by dx ry1. And derivative of e power x is e power x itself. And this derivative is required at x is equal to 0 and y is equal to 1. Therefore, y1 is equal to e power x and x is 0. Therefore, y1 is equal to 1. Again, differentiate with respect to x. Derivative of y1 is y2. Derivative of e power x is e power x itself. At 0 comma 1, this will be e power 0 and e power 0 is 1. y1 is equal to 1 and y2 is equal to 1. Therefore, rho is given by 1 plus y1 square. 1 plus y1 square and y1 square is 1 whole power 3 by 2 divided by y2 and y2 is 1. 1 plus 1 is 2 2 cube is 8. 8 power 1 by 2 means square root of 8. Square root of 8 is 2 root 2. Or you just write like this, 2 power 3 by 2. In either ways you can write. You either write 2 power 3 by 2 or you write 2 into square root of 2. Next, last part of this module, center of curvature and circle of curvature. Center of curvature, circle of curvature, and evolutes. Center of curvature, circle of curvature, and evolutes. Let's consider a curve like this, AB curve. Any arbitrary curve. Now let's mark an arbitrary point P here. Any point, it represents every point on the curve. And keeping this part as a part of the circle, we construct a circle or imagine a circle or complete a circle like this. Keeping this as a part of the circumference, we construct a circle. Then center of this circle is called as center of the circle. Center of the circle is center of the circle. And this circumference is called circle of the curvature. This is called circle of the curvature. And you know that this radius is a radius of curvature. It is denoted by rho. This is one circle corresponding to the point P. How many such points are there? Infinite number of points are there. If you consider P here, you will get one more circle and the center will be somewhere here. If you consider a circle here, center will be somewhere here. Similarly, you can construct infinite number of circles corresponding to these arbitrary points. If you join all these circles, you can trace a curve like this. That means this circle is a moving point and the path traced by this circle is called locus of the point. Locus of the point or locus of the center. Locus of the center. Similarly, you can construct infinite number of circles here. There will be infinite number of centers and all the centers are joined by a curve, and that curve corresponds to a moving point that is called center of the curvature, and the locus of this center of the curvature, locus means path traced by the moving point under certain conditions, is called as evolute. Locus of this center is called as evolute. That means evolute is described in terms of center of the curvature. Center of the curvature is denoted by x bar comma y bar. Center of the curvature is, this center is denoted by x bar comma y bar, where x bar is x minus y1 into 1 plus y1 square divided by y2, and y bar is y plus 1 plus y1 square whole divided by y2. That means that's evolute. Evolute is the locus of this point, is described in terms of x bar and y bar. That means we have to eliminate x and y while finding evolute. Is this definition clear?
Yes, sir.
Okay. And equation of this circle, this is a known equation. You know what is the equation of a circle in terms of center and radius? That is always given by x minus x bar whole square plus y minus y bar whole square is equal to r square. R is radius. Here radius is rho. Therefore, this is rho square. X minus x bar whole square plus y minus y bar whole square is equal to rho square. This is circle of the curvature. Find the coordinates of center of curvature of this circle. Y is equal to, sorry, curve y is equal to x square at 1 by 2 comma 1 by 4. Find the coordinates of center of curvature. That means x bar and y bar are to be determined. Y is equal to x square. This is the given curve. First, you find first and second order derivatives corresponding to this curve. Y is equal to x square. Now differentiate with respect to x. Derivative of y is y1. Y1 is equal to derivative of x square is 2x. You can put your attendance now. Only 10 minutes left. Okay. Differentiate with respect to x. Derivative of y is y1 and derivative of x square is 2x. And this derivative is required at a point where x is equal to 1 by 2 and y is equal to 1 by 4. Substitute. When x is equal to 1 by 2, this will be 2 into 1 by 2. And 2 into 1 by 2 is 1. Therefore, y1 is equal to 1. Again, differentiate with respect to x. Derivative of y1 is y2 and derivative of 2x is 2. This is a constant. Therefore, you need not apply this point. Y1 is 1 and y2 is 2. Now we find center of the curvature. Center of the curvature given by x bar comma y bar, where x bar is x minus y1 into 1 plus y1 square divided by y2. This is the expression to find x bar. Substitute x. Here x is equal to 1 by 2. This is x and this is y. X is equal to 1 by 2 minus y1. What is y1 here? Y1 is 1 minus, I substitute here. X minus, x is 1 by 2 minus y1 and y1 is 1 into 1 plus y1 square, that is 1 plus 1 divided by y2. Y2 is 2. Therefore, this is equal to half into, half minus 1 plus 1 is 2, 2 by 2 is 1. Half minus 1. Half minus 1 is minus half. X bar is equal to minus half. Similarly, we find y bar. You note this difference. Y bar is given by y plus, there is no y1 here. Y bar is equal to y plus 1 plus y1 square divided by y2. I substitute. Y plus, y is 1 by 4 plus 1 plus y1 square. 1 plus y1 is 1 and y1 square is also 1 divided by y2. Y2 is 2. Therefore, this is equal to 1 by 4 plus 1 plus 1 is 2. 2 by 2 is 1. 1 by 4 plus 1 is 5 by 4. Therefore, center of curvature x bar comma y bar is equal to x bar is minus 1 by 2 comma y bar is 5 by 4. Is this clear?
Yes, sir.
ಹೌದಾ
ನಾನು ಅವತ್ತು ಅಷ್ಟೇ ಕೇಳಿಲ್ಲ ಅನ್ಕೊಂಬಿಡಿ ನಾನು ಮೀಟಿಂಗ್ ಐತೆ
is 4.
Yes, sir.
Yes, sir.
Find the coordinates of center of curvature of the curve y square is equal to 4ax at a t square comma 2at. Some kind of problem. Y square is equal to 4ax. Find the coordinates of center of curvature of the curve y square is equal to 4ax. First we find y1 and y2. Differentiate with respect to x. Derivative of y square is 2y. Derivative of y square is 2y and the derivative of y is y1. This is equal to 4a is a constant, keep it as it is, and derivative of x with respect to x is 1. Therefore, y1 is equal to 4a divided by 2y. 4a divided by 2y, which can be written as 2a divided by y. And this derivative is required at a point where x is equal to at square and y is equal to 2at. Substitute. This is equal to 2a divided by y and y is 2at. Cancel this 2a with this 2a, you get 1 by t. y1 is equal to 1 by t. Next we find y2. To find y2, differentiate y1 with respect to x. Derivative of y1 is y2. Here 2a is a constant, keep it as it is. Derivative of 1 by y is minus 1 by y square. 2a is constant, you keep it as it is, and derivative of 1 by y is minus 1 by y square, and derivative of y is y1. Substitute. This is equal to minus 2a divided by y square. Y is 280, this is y. Y is 280, therefore y square is 4a square t square into y1, and y1 is 1 by t. This is equal to minus, this 4 is exactly divisible by 2 times. Here cancel this a with this a. You get minus 1 divided by 2a t cube. y1 and y2. Now we find the coordinates of center of curvature x bar and y bar. X bar and y bar. First let's take up this x bar. X bar is given by x minus y1 into 1 plus y1 square divided by y2. X is specified at square. It is the point at which the center of curvature is determined. That is at square comma was y 280. Right. at square comma 280. This is the point. X minus x is at square. It is substituted here. Minus y1. We just found that y1 is equal to 1 by t plus into 1 plus y1 square. y1 is 1 by t, therefore y1 square is 1 by t square divided by y2. And what is y2? Minus 1 over 2at cube. We just obtained this result. y2 is minus 1 by 1 divided by 2at cube. This is equal to a into t square. Now minus into minus plus. Transform this 2at cube to numerator. You get 2at cube divided by t. And 1 plus 1 over t square can also be written as t square plus 1 divided by t square. T square into 1 is t square plus 1 divided by t square. Now this t into t square is t cube. Cancel with this t cube. At square plus 2a into t square 2at square plus 2a into 1 is 2a. Therefore, 8t square plus 2at square is 3at square plus 2a. This is x coordinate of the center of the curvature. Next, y coordinate. Y coordinate is given by y plus 1 plus y1 square divided by y2. Y is 280. 1 plus y1 square. y1 is 1 by t. Therefore, 1 plus 1 by t square divided by y2, and y2 is minus 1 over 2at cube. Therefore, 2at plus into minus minus, transform this to numerator, 2at cube. 1 plus 1 over t square can be written as t square plus 1 divided by t square. Here, cancel this t square with the t square here. What is left here? Only 2at. This is equal to 2at minus 2at into t square is 2at cube minus 2at into 1 is minus 2at. Cancel this 2at with this minus 2at. You get minus 2at cube. Therefore, x bar comma y bar is x bar is 3at square plus 2a and y bar is minus 2a t cube. This is what we require.